Evening, students. So I think,
Good evening, sir.
good evening, good evening, good evening. How are you? Everybody is fine.
Yes,
So
sir.
Fine, sir.
very good, very good. So okay. आप अगर कुछ नहीं बोलोगे तो मैं समझूंगा आप फाइन हो. Okay. Okay, okay. So it's the first time I haven't seen my students directly. Huh? But we are working in the different abstract world, isn't it? Okay. Someday we have a different chat session such that I can see at least who is the part of this all sessions, isn't it? Okay. So right now we are just going to finish our topic, and obviously this topic is mass energy equivalence. And on Monday, we will go for 4 vectors. So we will have also one topic of 4 vectors. And when we will finish our course at the end, in month of maybe October or November, we will go for relativistic electrodynamics and relativistic quantum mechanics. So again, this thing will come into picture. But up to classical mechanics part, we are just going to till Monday. So somebody is asking test. You can decide when you want to give test. But before that, I will suggest you just at least do all the problem of your class notes and assignments. So once you do it, then you can perform well into test. There is not any problem. So we will conduct a test. We will conduct everything, doubt classes, test, everything we will conduct. So let's try to finish this mass energy equivalence. So today's class, we have some student in last class said, sir, where is conservation of energy? Where is conservation of momentum? So today we will see all the part of conservation and energy and momentum. But the most exciting thing of today's class is all about talking about massless particle. So how we can have concept of massless particle. So this is one of the exciting thing in today's class. But although we have everything is very exciting. So let's come to mass energy equivalence. So obviously what we have in last class, we have seen that mass m is equal to m naught root under 1 minus u square c square. You can write u, c, anything. This u is relative speed of mass with respect to observer. M naught is rest mass. And we have this P is equal to mu root under, and this is m naught u, 1 minus u square c square. I have given you one particular exercise to do. I hope this is quite simple exercise. So what you will get? You will get E square is equal to P square C square plus M naught square C4. So we will see this is one of the wonderful expression of energy and momentum. The energy momentum expression is very important expression. Why? Because in the classical mechanics and in the quantum mechanics, we have this sort of information. So there it will be worked very nicely. Now, one of the wonderful thing, if I am going to plot m versus u, what I am going to plot, if I am going to plot m versus u, then this will be something like this. So this will be m, and in this 6 is u, and what we have some m naught. So if u is equal to 0, m is equal to m naught, and there is a saturation point u is equal to c. So we will start here, and as your mass will going to increase and increase. So this, but it will never touch at c. It is never touch at c. So this will be m versus u. This is not cu, this will be u. And this particular value is c. is nothing but 3.3 into 10 to the power 8. So 3 into 10 to the power 8 meter per second. So this is M versus C. Now look at this particular thing. This is very interesting. This is total energy square. So this is total energy square. And this is nothing. So this term is known as, this term is E square, total energy square. And this term I can write P into C whole square. And this term will be M naught C square whole square. And obviously, this term is nothing but M naught C square, and this is rest mass energy square. So this is rest mass energy square. This is total energy square. So this is total energy, and this is rest mass energy. If I will ask you, what is PC? Which physical quantity it is going to tell? The most of people is confused that PC is something like kinetic energy. No. This is wrong conception. Look at here. Why it is wrong conception? Because what is E? E is equal to kinetic energy plus M naught C square. If you are squaring on both sides, then what you will get? You will get E square is equal to T plus M naught C square whole square, and which will be equivalent to, T square plus M naught square C4 plus 2 times T M naught C square. So this thing can be written as, T square plus 2T M naught C square plus M naught C square whole square. And this is your E square. So if you are going to compare this thing, if you are comparing, this is, let's say, equation A and equation B, then E square will compare to E square. M naught C square whole square is compared to M naught C square whole square. And this term will tell you about PC square. So here, so this is not T naught, this is T. So if we will compare it, this is some mathematical quantity, that is T square plus 2T M naught C square is equal to PC whole square. Please mind it, this is not any physical quantity kind of thing. आप इसे kinetic energy नहीं कह सकते हो. So if somebody have this confusion, lot of people, this is my experience in my classroom. Whenever I ask the people that what will be this particular thing, he will say kinetic energy square. No, absolutely not. This is not kinetic energy square. This is something momentum into c. That's it. Magnitude of momentum into speed of light. That's it. Nothing else. So this is P into C. And this will be M naught C square square. So this is rest mass energy square. This is energy square. So total energy is equal to rest mass energy plus kinetic energy. This is absolutely correct. So total energy is equal to rest mass energy plus kinetic energy. But when you are squaring the thing, you can easily compare what is going to happen. So first, my request is, if you have this sort of notion that this is PC is some kinetic energy square, this is wrong. This is some momentum into speed of light. This is magnitude of momentum into speed of light. This is nothing but magnitude of momentum. Please mind it. Magnitude of momentum into speed of light. So if you have any doubt, then you can just ask me. Then I will go next level of calculation.
नो सर.
अरे मैंने नो बोलने के लिए थोड़ी बोला था, कितनी बार सिखाया हूं. शांत रहोगे इसका मतलब है कि आपकी डाउट नहीं है. ओके, सो let's try to analyze what is happening here and which kind of beautiful symmetry and beautiful law we can see here. This is very interesting. So let's go for
एक्सक्यूज मी सर।
बोलिए।
सर इसमें ये समझ में नहीं आया सर, इसमें प्रूफ क्या किया हमने?
हमने ये प्रूफ किया कि ये काइनेटिक एनर्जी स्क्वायर नहीं है। मैंने प्रूफ कुछ नहीं किया, आपकी कंफ्यूजन को ठीक किया है। ठीक है, हमने भी प्रूफ कुछ भी नहीं किया है। हर जगह प्रूफ करने के लिए थोड़ी बैठे हुए हैं। आपके क्लास में कई ऐसे बच्चे होंगे जिनको ये कंफ्यूजन होगा कि ये काइनेटिक एनर्जी स्क्वायर है। मैं ये दिखा रहा हूं कि ये काइनेटिक एनर्जी स्क्वायर नहीं है। ठीक है, नाउ लुक एट हियर व्हाट वी आर गोइंग टू एनालाइज। दिस इज वेरी इंटरेस्टिंग। So what we have E square is equal to P square C square plus M naught C square whole square. And now look at, if we can recall the Pythagoras theorem, so we can have H square is equal to P square plus B square. Remember, this is something like Pythagoras theorem in our class 8th, 8 या 7 है ना? So now if I am taking y-axis as PC, x as m naught c square, then this particular value, this particular value will be E, isn't it? This is PC, this is m naught c square, then this particular value is E. Then only you can write E square is equal to PC square plus m naught c square. So we have this triangular symmetry in this particular expression. And how we can use this triangular symmetry? Now look at what will happen when for the given value of energy, if rest mass is going to decrease. So if rest mass is going to decrease, the energy will be approximately parallel to this PC. Suppose we are suppose this is given value of energy, the rest mass is decreasing. So this will be something like that. Again, it will decrease. It will be something like that. Again, it will decrease. It will be something like that. And finally, when rest mass is equal to 0, then we will land at here. So when my rest mass m naught is equal to 0, what we have? We have a wonderful expression, E is equal to P into C. And here we have concept of momentum. Here we have concept of momentum, and that momentum is E upon C for those particles whose rest mass is 0. So here we can make a concept that there may be existence of particle whose rest mass is 0, but it has momentum. So, and what will be that momentum? That momentum will dependent on energy. And this energy is equal to E upon C. Sorry, this momentum is equal to E upon C. So which type of particle is this? So obviously, only one particle we know, and that particle is identified as photon. What is photon? Photon has rest mass m naught is equal to 0. So photon has rest mass 0. And what will be momentum? Momentum is equal to E upon C. Even if it is massless, it has momentum. Why it has momentum? Because it has energy. So from where it is getting the energy? We know for the photons, we have seen in the photoelectric effect and all these things, we have seen that photon have energy is due to frequency. So that photon have energy due to frequency. So what is conclusion here? The conclusion here, and what is photon actually? Photon means the speed is speed of light. If any particle is moving with the speed of light, then it will be assumed to be massless, and it will treat it just like a photon. And what is photon and what is momentum of photon? This will be P is equal to E upon C. So we have one beautiful concept, and you can write this concept. When particle is massless, so massless means rest mass is 0, which means the velocity is equal to c, which means the momentum is written as E upon c. And what will be this E? This E is nothing but h nu upon c. We know from the modern physics and all this photoelectric effect and all this thing, this is massless particle is treated as is dependent, energy is dependent on frequency. So we have a very interesting calculation from this particular expression that we can say about this is massless particle can exist with some momentum. Massless particle can exist with some momentum, and in some problem different particle will also assume to be massless. So if particle is assumed to be massless, you will think that particle is moving with the speed of light. So only one particle will moving with the speed of light, which will be massless. आप उसका नाम चाहे दो, जो चाहो वो दे दो. यहाँ पर हमने नाम उसका क्या देखा है? Photon दिया हुआ है. And this is your assumed to be massless. In lot of problems for the calculation purpose, we assume the very lightest particle is assumed to be massless. What is meaning of that? Meaning of that particle is moving with the speed of light. So this is one of the wonderful use of this particular expression. From this particular expression, we can have a logic that massless particle can exist. So what will happen when V is equal to C? So you cannot say when V is equal to C, then it will become infinite mass. No, there is not infinite mass exist. When V is equal to C, then particle will be massless. This is the wonderful thing. This is the wonderful thing. You cannot say, so why we have added in a postulates that any materialistic particle cannot have a speed which will equal to speed of light. So if particle have mass, then it is assumed to be speed of light less than c. But if it is massless, then obviously they will move with the speed of light. And this is the wonderful thing we are getting from this particular equation. So if you have any doubt, you can ask me, then we will go for problems.
Excuse me, sir.
Yes.
Sir, hypothetically अगर हम ऐसे consider करें क्या तो हमने पहले देखा था कि when a particle has a तो उसका मास हमें अपने frame of reference से it is greater than m naught, right? तो अगर
सुन रहा हूँ.
तो अगर हम v अगर से c तो फिर उसका मास बढ़ते जाना चाहिए, राइट? हमने देखा.
लेकिन ये इसके लिए है. अरे भाई वही तो मैं अभी तुरंत क्या बोला. मैंने ये कहा कि आप v इज इक्वल टू सी जैसे ही करोगे, अगर किसी भी पार्टिकल की स्पीड आप स्पीड ऑफ लाइट से दौड़ा दोगे तो वो मासलेस हो जाएगा. ये फॉर्मूला आपका तभी लगेगा m इज इक्वल टू m नॉट रूट अंडर 1 माइनस u स्क्वायर अपॉन c स्क्वायर. ये फॉर्मूला का आप यूज तभी कर पाओगे जब u की वैल्यू अल्फा c है. मैंने इसमें टच थोड़ी, आपकी पॉसिबिलिटी ही नहीं है कि आप किसी भी पार्टिकल अगर उसकी मास है तो उसको c स्पीड से आप दौड़ा सको. दिस इज नॉट पॉसिबल. बट समहाउ इफ यू आर डूइंग दिस, which means the particle will not going to infinite, the particle will become massless. This symmetry does tell you this thing ना. अभी जो मैं दिखा रहा हूं उसमें क्या दिख रहा है, यही चीज तो दिख रहा है. So this is your E, this is your PC, and this is m naught c square. अगर mass is equal to m naught है तो E की वैल्यू क्या हो जाएगी, PC हो जाएगी. m naught की वैल्यू अगर मैं 0 पुट करूं तो E की वैल्यू क्या होगी, PC. This term will be there.
Okay,
and it is existing in life. So why you are using hypothesis? Agreed or not? So there is not any need of unnecessary hypothesis. There is need of to fulfill the expression which will satisfy the observation. So here it is satisfying the observation. Please unmute कीजिए जिनका भी, sorry, please mute कीजिए जिनका भी unmute है. So this thing will satisfy the observation. You have the particle which is massless, and that is photon. And photon have a speed of light, and which is massless. We assume photon is massless. Nobody have measured the weight of and mass of photon, but it has momentum, isn't it? So this thing is only for the materialistic particle, isn't it? If particle is matter, means it has mass, but this is for the massless particle. So you have two theory. One is for mass particle and one is for massless particle. And both theories satisfied. Actually, this is the beautiful part. Okay. So you cannot say, एक minute, you cannot say this will match to this and this should be matched to this. No, two are separate thing. हाँ बोलिए.
Sir, these same things are valid for neutrino case also.
अगर आप न्यूट्रिनो को massless मानते हो तो,
मतलब this thing must be mentioned in the question.
yes, yes, very good, very good, very good. This should be mentioned into question. वही मैं करवाऊंगा, अभी तुरंत क्वेश्चन करवाऊंगा, ठीक है? If it will be mentioned into question, means it is massless. ठीक है? So let's go for problem. Problem करने से दिमाग ज्यादा बढ़ेगा, है ना? ठीक है, फटाफट म्यूट कर लीजिए, है ना? Okay, so let's go for next problem. So let's go for some problem, and then you can realize what is going to happen here. So first तो एक, and देखो in general हमारी आदत क्या होती है as a human being, as a mediocre student, and we all are very average kind of a student, है ना? So it is our basically nature that we want only one formula and that should be applied to everywhere. This is our inherent nature as a student of physics. But there are different cases. There are different circumstances. And you have to treat all circumstances different. Massless particle is different circumstances. The particle which has mass is different circumstances. So this is a wonderful thing. Agreed? And ultimate aim is to finding the very natural unification theory which will deal to everything. But before that, we have to read each thing separately. आगे जाकर के तो आप देखो कि इलेक्ट्रोमैग्नेटिक थ्योरी, क्लासिकल मैकेनिक्स सारे एक ही जगह जाकर के मर्ज करने की कोशिश करेंगे. But that is the not case right now. Okay, so try to be understand every topic in bit by bit. Okay, so let's go for a simple problem. Again, the momentum of a particle is 3/4 m naught c. So this is momentum of a particle with rest mass m naught. Find the energy of a particle and find the kinetic energy of a particle. So you can, कल इस पर हम लोगों ने speed भी निकाला था, remember? The same के लिए speed निकाला था with mass. But today I will use different thing. So today, so what will be, if momentum is given, then you have E square is equal to P square C square m naught square C4, and this value, so you can write E is equal to root under, and that will be 9/16 m naught square C4 plus m naught square C4. So what will be E? E is equal to, I think, 5/4 m naught C square. Very simple, very simple. How, when you are using which formula, it's a matter of choice. Obviously यहाँ पर मुझे सीधा एनर्जी निकालना है, तो मैं क्यों वेलोसिटी निकाल कर फिर एनर्जी निकालो? We can directly go from there. And you remember, tomorrow we have also getting this kind of situation. And what will be kinetic energy? The kinetic energy is equal to E minus m naught C square. So what will be this value? This value is 5/4 m naught C square minus m naught c square. So this will be 1 by 4 m naught c square. It's very simple. Just 1 marks question into GATE or कि आपको formula याद है या नहीं. But let's do some application. Let's do some application. And yes, the application is all about conservation of momentum and conservation of energy. So this is quite simple problem. Let's go for what is conservation of energy and what is conservation of momentum. So first I am going to explain you which kind of system we are dealing with. Suppose we are dealing this kind of system. The two particle is there and it is collide, and after the collision they are moving together. This can be one situation. One particle is there, it will be decay into two part, and one will go into this side, another will go into this side. This can be another system. So we have collision problem, we have decay problem, all different type of problems we can have. So how we will approach this type of problem? Suppose we have this kind of situation. Suppose we have some particle, pion is there, and it will be decay into muon and neutrino. Suppose this kind of situation is there. And suppose this pion has some momentum, let's say this has some momentum, and we have to find the momentum or energy of neutrino and muon. So these all processes are due to internal forces. So obviously some forces will act, but these processes are due to internal forces. So maybe they can be to just decay, a spontaneous decay kind of situation, and we have two particles. So if there is internal forces are involved into all this process, then momentum must conserve. When momentum is not going to conserve, when we have external forces involved, suppose इसके ऊपर हम कुछ pressure लगाते, कुछ force देते, then momentum is not going to conserve. It is naturally going to decay. It's nature. It's naturally going to decay. And it is due to internal forces. So why momentum will be conserved? What is meaning of momentum will be conserved? Meaning of momentum will be conserved. In last class, some girl have asked me that, sir, where is momentum is conserved? Meaning of momentum is conserved means momentum of pion must be equal to momentum of neutrino plus momentum of muon. And please mind it, this is vector quantity. Momentum is always vector quantity, so you will take the x-axis along x-axis, y-axis momentum along y-axis. So this kind of, but more or less most of the case you have only one-dimensional case. But I have given you for the two-dimension in the assignment. But we will just start with one-dimension case. But you have to always remember these are vector quantity. So please mind it, momentum of a system is going to conserve. You cannot say momentum of this particle is going to conserve. No. What is system here? Before the collision, this is my system. Before the collision, this is my system. And after the collision, these two particles is my system. You cannot say the momentum of muon is conserved. This had not any sense. So why I have told you what is meaning of that? That you are asking, sir, where is momentum is conserved? Always you will talk about the system. So this is your system before the decay, and this is the system after the decay. Similarly, we have to write energy before the collision or before the decay must be equal to energy after the decay or after the collision. So sometime we have collision problem, sometime we have decay problem. And now what is the best thing to use here? The one of the important aspect of this particular formula, E square is equal to P square C square m naught square C4, that in the energy we have expression of momentum, and here will be also expression of momentum. So variable will be ultimately reduced. You will see how we are going to discuss all this problem. So always try to think about system. Don't try to think about the particle की momentum conserve रहेगी, एक particle की momentum conserve रहेगी. No, you have always the conservation of momentum of a system. So let's go for some problem, and then we will try to see how we can approach different type of situation. So let's go for first problem, and every problem is very important and they are directly coming to your examination. So please do it, do practice. Now, so let's have one particular problem. So there is a pion, and pion is decay into muon plus neutrino. Suppose this kind of situation is there. So pion is decaying into muon and neutrino. So let's write a pion is decaying into muon and neutrino. This pion is pi. So muon and neutrino. If rest mass of, and pion is in rest, pion in rest. Sorry. So I have missed here. A pion in rest or pion at rest. Pion at rest. So pion at rest decays into, so now language is correct. The pion at rest decays into muon and neutrino. So this will be muon and neutrino. The rest mass of pion is m pi. Rest mass of muon is equal to m mu. Rest mass of neutrino is equal to m nu. So all have mass, it is given. Then find the energy of muon. Which type of energy? Outgoing energy. Find the outgoing energy of muon and neutrino. So what is given thing? The given is m pi, m mu and m nu. So you have to find each and everything in terms of masses. So you have to find the energy and energy of muon and neutrino in terms of mass. These masses, so these are given variable. So these are given parameters. So you have to write energy as a function of m pi, m mu and m nu. That's it. Not any momentum is given, nothing else is given. Only the rest mass is given, and all are the rest mass. So only rest masses are given. How you will approach this type of problem? This is one of the challenge. How you will approach this type of problem? So let's try to see the approach of problem. So obviously, कई बच्चे ऐसा करते हैं कि अपनी तरीके, just they will take the momentum their own and they will write answer in terms of momentum. No. You have to find unknown quantities in the given known quantity. What are given known quantities? The given known quantities m pi, m mu and m nu. That's it. There are not any another thing. So you have to write each and everything in terms of mass of pion, mass of muon and mass of neutrino. So I think the problem is very clear. So let's see how it is going. And it is also not given that this is going in which direction, this is going in which direction. Everything have to be done by you. हर एक चीज आपको खुद ही करना होगा. So let's try to do this thing. So I hope you understand the problem. Now, so first thing we will go for conservation of momentum. Obviously, I have told you that these type of process are due to internal forces. So you have to just talk about conservation of momentum. So first we will go for conservation momentum. Pion is at rest. Please mind it. It is at rest. Pion is at rest. If pion is at rest, then what will be momentum of pion? 0. So momentum of pion is 0. I am using conservation of momentum. Conservation of momentum. So pion is at rest. So this has 0 momentum. And after the decay, it has 2 particles. And if it is 2 particles, then both have to have some momentum. So what will be, let us assume the momentum of muon is P mu plus momentum of neutrino is P nu. I am using the vector condition. So I have started with the scratch. From here, what is meaning of that? Meaning of that, P mu is equal to minus P nu. P mu is equal to minus P nu. What is meaning of that? Meaning of that, the pion is at rest and suddenly it will decay into 2 particles. So what will happen? If one particle is moving in this direction with some momentum P mu, then another particle have to move in exact opposite direction P nu, such that the total momentum of the system must be equal to 0. So why I can say the magnitude of P mu must be equal to magnitude of P nu is equal to P. Do you understand this concept? If anybody has doubt, then you can ask me. Okay, it's a very simple. The momentum must be conserved. So look at, due to conservation of momentum, we reduce one variable. यहाँ पर 2 variable था. What we have done? We have reduced this variable. So mod of P mu is equal to mod of P nu is equal to P. And now,
सर एक कंफ्यूजन है थोड़ा सा.
क्या
सर
confusion
आपने
है?
कहा कि ड्यू टू इंटरनल फोर्सेस फर्स्ट वी कैलकुलेट कंजर्वेशन ऑफ मोमेंटम. सर ये ड्यू टू इंटरनल फोर्सेस के कारण क्यों है?
ये क्या बकवास है? ये क्या बकवास है? ये मैंने कब कहा कि ड्यू टू इंटरनल फोर्सेस वी हैव? मैंने ये कहा कि ड्यू टू इंटरनल फोर्सेस दिस इवेंट इज गोइंग टू हैपन.
ओके सर.
और इफ देयर इज,
जी सर.
तो फिर कंजर्वेशन मोमेंटम होगा.
ओके सर.
कंजर्वेशन ऑफ मोमेंटम के लिए एक्सटर्नल फोर्स 0 होना चाहिए. अरे ये तो क्लास 10th की चीजें हैं भाई. So this will be, so you can have this particular thing. So momentum of muon, the magnitude of momentum muon must be equal to magnitude of momentum of neutrino. Please mind it, they both will go into opposite direction because they must conserve the momentum. अगर दोनों same direction में जाएंगे तो इनकी momentum 0 कभी नहीं हो सकती है. Its momentum will be 0 only if both will move in opposite direction. Now, the next thing we are going to write conservation of energy. So this thing we have one particular relationship we have get here, that P mu is equal to, let's say I am putting the magnitude, P nu is equal to P. So this is one particular thing. Now we have to write energy of pion must be equal to total energy of muon plus total energy of neutrino. And please mind it, there is not any heat loss kind of thing is there. So why I am not using extra energy term. So total relativistic energy is going to conserve. So what is going to conserve? Relativistic energy. So this is your relativistic energy. So now, what will be relativistic energy of pion? It is at rest. So pion is at rest. So we have only rest mass is associated there. So pi c square. This is rest mass of pion. And here we have rest mass of, but muon has not only rest mass, it had momentum as well as rest mass. So what will be energy of muon? The energy of muon, this is total energy, P mu square C square M mu square C4. So E square ko maine, this is for the muon. And next we have to write for the neutrino. So what will happen for neutrino? So for neutrino, we have to calculate P nu square C square. Obviously it has momentum as well as mass. So this will be M mu square C4. So this is all about neutrino. And we have mod of P mu is equal to mod of P nu is equal to P. So we can just replace it. So we can have M pi C square, and this value is equal to P square C square M square C4 plus, again I can write P nu is equal to P square C square plus, sorry, M nu, na? This is M nu. So this will be M nu square C4. Please mind it. This is the thing. Now, this is nothing but E nu. So we have to find E nu as well as we have to find E nu. So this is for E nu. So once you will get the value of momentum, then you can find E mu as well as you can find E nu. But how you will getting the value of momentum? So there is a star mark. How? यहाँ तक तो कर लोगे. But what about calculation part? How you are getting calculate this thing? देखो क्या गड़बड़ी होने वाली है. If you and just do it in homework little bit, give 10 minutes, 20 minutes, so you will feel the problem. But I am just giving you feeling of actual thing. So what you will do, you will take it in this part and you will do the square thing. So what will happen? One square will be gone, and here one square will gone, but there is 2ab term kind of thing is that. You can write something, suppose this is B plus C, and here is, let's say this is A. So you write just, you will take it 1 minus B whole square is equal to C square. When you will go for 1 minus B whole square, then you have A square plus B square minus 2AB. Once you will again get 2AB, then root will be again there. So if root will be there, then you have to go again square. And then this equation will become a very complex. So this is going to be very, very complex kind of situation. So if you want, you can just do it in home, just find the value of P. It is very difficult to find the value of P from here because there is two root situation is that. So you can just use this thing. So again, one root will be again survive there. So what will be equation? Equation will be P to the power 4. So it will be very difficult. So let's go for a trick to how you are going to solve this type of problem. So let's go for trick. यहाँ तक कुछ पूछना है तो पूछ लीजिए, because I have to rub everything. Okay, so let's go for a wonderful trick. So trick is very interesting. What is trick? Please mind it. We have introduced momentum from our side. Our side means this is unknown variable. We have to write energy in term of only masses. So we have to remove momentum from the calculation. What we have to do? We have to remove momentum from the calculation, and we have to find E mu and E nu in term of only masses. So let's see how we are going to use this particular stuff. So this is very interesting. So this trick you should always remember when this problem will come into your exam. Otherwise, it will take at least 40 minutes to calculate each and everything. So what we have, the first equation is, we have E pi is equal to E mu plus E nu, and we have momentum conservation from there we have. So what we have from here, we have E mu plus E nu is equal to m pi c square. So this is my first equation. And look at the second equation, how we are getting the set. So we have to find E mu and E nu. So there are two variables. So we need two equation. Once you will get two equation, we can easily solve it. So let's see, this is my first equation. E mu square is equal to P mu square C square plus M mu square C4, and which can be written as, this P mu can be written as P square C square M mu square C4. And we have E nu square is equal to, again we can write P nu square C square M nu square C4, and this will be P square C square M nu square C4. So how you are getting, how you will remove PC? How you will remove P? Can anybody give answer?
Subtracting the two equations.
Subtracting the two equation. Very good, very good. So we are just going to subtract this equation. So when we are going to subtract this equation, what you will have, E mu square minus E nu square, and this term is going to cancel out, and we have M mu square C4 minus M nu square C4, and here again we can write A plus B into A minus B. So this equation can be written as E mu plus E nu into E mu minus E nu, and this must be equal to M mu square C4 minus M nu square C4, and again we have E mu plus E nu is equal to M pi C square. So we have second equation. The second equation is E mu minus E nu is equal to M mu square minus M nu square C square by M pi, isn't it? This will be M pi C square. So one C square will cancel. So this will be two equation. So this is equation A, this is equation B, and you can just solve it, this equation. So take 30 seconds and solve it. And don't tell answer, you can just mess the answer. Just do it with yourself. Just solve at least once. E mu की value निकालिए, then you can match the answer. Okay, so I think you can get this answer. So you can just match it, no need to respond, just match the answer. So you will have E mu is equal to M mu square, sorry, E mu is equal to, you will get m pi square plus m mu square minus m nu square c square upon 2m pi, and we have E nu is equal to m pi square plus m nu square minus m mu square c square by 2 m pi. So I hope you can get this answer. So this is a first question we can have. Now let's go for second. If you have any doubt, then you can ask me. Okay. So let's go for next problem. So at least we will do 3 problem at least. Then in the next class we will do 1 or 2 more problem, and then we will finish with the basic vectors. Okay. So same problem, but right now I am using some different facts. What is going to happen? So this is some pion. It will be decay into muon plus neutrino. So what is given? Pion at rest decays into muon and neutrino. So pion at rest decays into muon and neutrino. Rest mass of pion is m pi. Rest mass of muon is m mu, but neutrino is assumed to be massless. Now you can see this is massless. Neutrino is assumed to be massless. So what will be problem? The first problem is find the energy of muon and energy of neutrino. Second problem, find the momentum of muon and momentum of neutrino. I am talking about magnitude. And third problem, find the velocity of muon and velocity of neutrino, or speed of muon and speed of neutrino. So what I have changed that this has not mass, it is become massless. So if it is become massless, then thing is going to change. So let's calculate it each and everything again. So again we will start with the conservation of momentum and conservation of energy. If you have any doubt, just right now you can ask me, because I have to just delete all this thing. It's a very same problem, but parameter is changing. We have to give the answer in term of m pi and m mu. That's it. So parameter is going to change. So let's go for this particular problem. It's a very nice problem, and in the examination you have at least one thing in every examination. Something, sometime energy, sometime momentum, sometime speed, and everything. So let's try to do. So obviously this is at rest again. So this momentum is 0, and this will be equal to P mu plus P nu. Please mind it, this is massless. Even if this is massless, it has momentum. Don't worry. You cannot say that it is massless, so let's momentum is zero. It can never be happen. If its momentum will zero, then its momentum will also zero. और ये कभी नहीं हो सकता है कि रेस्ट में पार्टिकल हो और रुका हुआ रहे दोनों पार्टिकल निकलने वाला. This is not going to happen. So obviously both have momentum. So again, you can see that after the decay, if muon is moving in this direction, this massless neutrino is moving in this direction such that total momentum is zero. So again you have P mu is equal to P nu is equal to P. So this kind of is there. So again we can easily calculate the energy. I am just writing it very fast. So we have E pi is equal to E mu plus E nu. So what is E pi? So we have E mu plus E nu is equal to m pi c square, and here we have E mu square is equal to P mu square c square plus m mu square c4, just energy equation. And we have here is momentum is also and rest mass is also, and we have E nu square is only P nu square c square. This is not there because it is massless. This particle is massless. So this is massless. So again we are using this particular thing. What we have, we can, and obviously you have P mu is equal to mod value is same. So you can just write P square c square plus mu square c4, and this will be also P square c square plus 0. You can put it here. Again we are going to subtract it. So when we are going to subtract it, we have again this type of situation. So we have E mu square minus E nu square is equal to basically m mu square c4, and again from here we can have E mu minus E nu is equal to m mu c square by m pi. So I am just doing again same thing, a plus b into a minus b, and we have this particular thing. So what we will get? We will get the two particular answer, and you can just check it by putting m mu is equal to 0 in the last problem. So let's going to solve this equation. If you will solve this equation, what you will get? You will get E mu is equal to m pi square plus m mu square c square upon 2m pi, and second thing will be you can just subtract it and then you can get particular value of E nu. So E nu is equal to something m pi square minus m mu square c square by 2m pi. So you can put in last question also, and you can put the value of m nu is equal to 0, then you have this particular thing. So first question I have done it. So I have deliberately rushed it, but now we can just think. If you have any doubt, just you can ask me, then we will go for momentum. Okay. मोनिका कोई डाउट है? Okay. So let's go for next one. Now we have to find the momentum, the magnitude of momentum. The momentum of E mu is equal to momentum of E nu. Yes, because we have this equation that momentum of mu is equal to momentum of nu. The magnitude will be same. So which equation you are going to solve? या तो आप पहले वाले को सॉल्व कर सकते हो या फिर सेकंड वाले को सॉल्व कर सकते हो. किसे सॉल्व करना चाहिए? बताइए, as a smart person, what will be expression of momentum here? The expression of momentum will be m. What will be this thing? This thing can be written as p square c square and mu square c4. ये होना चाहिए इसके लिए, yes या no? और इसके लिए क्या होना चाहिए? This value is equal to nothing but p into c, because it is massless, isn't it? So obviously you can solve from this also, you can solve from this also, both will give you same answer. इसे सॉल्व कीजिए या इसे सॉल्व कीजिए, दोनों से आपको क्या मिलेगा? सेम आंसर मिलेगा. So obviously as an intelligent person I must go for this, because we know this is massless, and if neutrino is massless, then what will be energy? The energy will be p into c. We have thus seen it will just act like as a photon. So what will be momentum? So momentum of muon must be momentum of neutrino. I am just talking about this will be p, and that value is equal to m pi square minus m mu square, and this will be c upon 2m pi. आप चाहो तो इसके थ्रू सॉल्व करके देख लो as your homework. Just do the practice from there. Just do the square part and just subtract this thing, then you can find the exactly same value. यहाँ तक कुछ है?
Sir, mu square should be there in E mu minus.
कहाँ पर?
Sir, in second equation, E mu minus E mu equals to mu square c square upon m pi.
This one?
No, sir, in the left part.
Left
Yes,
part? Here?
Yes, sir, here.
Oh, sorry. This will be mu square. This will be mu square. Yes. वहाँ square किया था ना? That will be mu square. Yes. So you will just go for mu square. Okay. So this is correction. In concept wise, it is okay. The final answer will be this thing. In my brain, it is going for mu square actually. So obviously, this is your momentum. Now we are going to find what will be speed. So just tell me what will be speed of neutrino? What will be speed of neutrino?
0.
How you will calculate the 0?
C, sir.
Exactly. The velocity of neutrino is c. Why it is c? Because it is massless. So why energy is equal to pc. Remember, जो मैंने लिखा था फिर से लिख दे रहा हूं. And is that, please mind it, both have same momentum. इसकी momentum और इसकी momentum same है. So its speed is c. So that its speed is also c. Never, no. Because it is mass. It has some rest mass. It has rest mass. So its speed must be less than c. So let's calculate what will be speed of this particular muon. So let's go for calculate the speed of muon. So I think up to this level, everything is okay. So let's calculate the speed of muon. So I have to use this thing, and so let's try to calculate what will be speed of muon. So what will be E mu? E mu in term of speed and rest mass is given by mu c square root under 1 minus u square c square. Let's say u is the speed of muon with respect to observer. Everything we are seeing is with respect to observer. So this must be equal
given
to,
that the mass of muon, sorry, mu is the rest mass of muon.
हाँ तो
So sir,
दिया हुआ नहीं है क्या? हाँ? क्या
yes
हो गया
sir.
फिर? तो क्या हो गया?
How we get sir, जब कोई speed के साथ होता है then m is equal to m naught under root of 1 minus mu square upon u square upon c square. So here
तो यही तो मैं लिखा हूँ, ये तो और क्या लिखा हूँ मैं?
yes sir, so here our m naught is mu, so
yes, तो क्या what is problem in there?
सर तो ये इसके साथ कोई वेलोसिटी कैसे हो, स्पीड कैसे हो?
क्या?
नथिंग सर.
अरे भैया वो तो v वेलोसिटी से जा रहा है ना, अगर मोमेंटम है तो उसमें वेलोसिटी है.
Yes sir.
If momentum is there, then there is velocity.
Yes sir, yes sir.
Then what will be observer feel? Heavy mass or rest mass?
Sir, heavy
mass. So I am writing heavy mass. Nahin?
Yes sir. Yes sir.
Yes. Okay. Thank you. So this will be m pi square plus m mu square c square by 2m pi. So what will happen? C square will gone. And I always suggest you to write 1 minus u square c square in one side. So write 1 minus u square c square. Let's write in one side. So what you have? You have this one. So it will go there and it will go there. So you have 2 m pi m mu upon m pi square plus m mu square. So what we will do? We will just go for squaring both sides and we will just subtract with 1. Then we have u square c square must be equal to u square c square 1 minus 4 m pi square m mu square by m pi square m mu square whole square. So obviously it will come to here. So this will be u square c square is equal to m pi square plus m mu square whole square minus 4. This will minus 4 m pi square m mu square by m pi square plus m mu square whole square. Now what will be happen to this part? What is this part? This is something. So I am just going to delete all this thing. So you have u square by c square. This thing is nothing, but I can write m pi square minus m mu square whole square by m pi square plus m mu square whole square. And now we can get the velocity of muon. This is nothing but the velocity of muon. Because muon has momentum, then it must have a speed. And what will be this value? This value is m pi square minus m mu square by m pi square plus m mu square into c. I can take guarantee that this value is what? Less than 1. Yes or no? Why it is less than 1? Because we know it has some mass. And any mass cannot have a speed of light. It will be always less than c. So you can have u is equal to some alpha c. And alpha is less than 1. And you can just check it. This will be less than 1. So this is nothing. You can say velocity of muon is u. So simple. Everything we are using from the very basic. Everything we are using from the very basic. So you can see. So I think the time is about to be finished. Okay. So 2 and 3 problem I will take into next class. Okay. So but concept is all over there. So we have to just go for 1 or more problem. So that will be come to the next class. So if you have any doubt, then you can ask me.
Sir. Sir, in this question, it was mentioned that neutrino is massless. If it is
mention
not
है
massless, if it is not massless, then we need to calculate the same steps for like while calculating. In this, we have taken velocity of neutrino is equals to c. But
because it is massless.
Because it is massless. But if it would not be in massless, then we need to calculate it same like E mu process.
हाँ बिल्कुल 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 बिल्कुल
Okay, thank you, sir.
ठीक है ठीक है सेम थी सेम बट वो नहीं आएगा आपके एग्जाम में है ना इट विल बी वेरी लेंदी ठीक है
Excuse me, sir.
so हाँ बोलो
Sir, we are finding velocity of muon. No?
yes
Sir, mu is right there.
yes sorry
Mu.
sorry ये लिख दिया क्या म्यून sorry this is v mu म्यून okay अरे इस पर मत जाओ है ना म्यून okay anything else these all are correction term if you have any so look at what we are doing the exactly very simple stuff we are just doing the conservation of momentum and then we are using the conservation of energy and how intelligently you are solving the problem that is different issue but only two concepts are there and always keep in mind when particle is massless then its speed is c or if particle is moving with the speed of light it is massless so यहाँ पर ऐसा नहीं हो रहा है कि आप तेज जाओगे तो हल्के भारी हो जाओगे so if you are moving with the speed of light then you will become massless and once you will become massless then you can go into the future it is not going to happen at least in 2020 I can say it with the guts it is not going to happen
तो सर हमें फ्यूचर में जाने के लिए मास लेस होना पड़ेगा सर
हाँ जी हाँ आप पूरा तेजी से कल से दौड़ना शुरू करो ठीक है
ओके सर
और फिर ठीक है और फिर मासलेस हो जाओ तो फिर आप फ्यूचर और पास्ट दोनों में चले जाओगे ठीक है so why we have this particular postulates this postulates is not any materialistic particle have a speed of light if particle have a speed of light this is only one thing that will be massless particle so at this note we are going to stop this session so on the Monday we are going to finish the 4 vectors okay so I think you can go to the assignment 2 also so if you want you can just go for assignment 2 so there are Saturday and Sunday you can just try to do assignment 2 जितना हो पाता है कीजिए otherwise I am always there okay don't worry everything will be sorted out ठीक है so let's see we have any doubt class on Sunday or not I haven't talked to management right now so but before that you have to go for assignments so we will maybe I will try to meet you on Sunday so Sunday तो सारे लोग free रहते हो ना so I कोई नहीं आप सतीश सर से बात कर लेना if doubt class will be there this will be Sunday or maybe I can take one doubt class on Monday and then we can go for class we can do also on Monday this thing so let's see what we are doing okay so thank you for everybody to learning all this stuff just revise it
Thank you, sir.
just revise it and I have seen that you must revise your notes very carefully okay so there are a lot of problems in your notes if you will see it will be going to bulky isn't it so anyway so we will also discuss how we will sort out these notes how we will revise once थोड़ा pressure और बढ़ जाए next week में फिर देखते हैं ठीक है thank you
थैंक यू सर
Thank you, sir.